Hi, so today in this video, we're going to be covering chapter 7.1.2, which is graphing the function f of x is equal to 1 over x. Let's just hop into it. We covered a lot of the things that we want to keep an eye out for in our last video, which was namely vertical and horizontal asymptotes as well as domain restrictions. Now we're going to put that into practice, but first what it wants us to do is test our knowledge with fractions. Let me just make a new layer. So, it says determine the function value for f of x is equal to 1 over x for the following values of x. So we have f of x equals 5 over 6, so it'll be 1 over 5 over 6. Now, if you recall, we know that this is technically like 1 over 1, 1 over anything. If you wanted, you could also put this into your calculator. Basically, what's going to happen is you're going to have 1 over 1 and then divided by 5 over 6, which is exactly the same as 1 over 1. Copy dot flip, so dot and then flip 6 over 5. You just basically do the reciprocal and change it to a multiplication sign instead of division, and then you get 6 over 5. So our first one is going to be 6 over 5. Same idea for the second one. We'll have 1 over 1 over 11, which is going to flip it. We'll have 1 over 1 times 11 over 1. I already skipped the copy dot flip part, and then you end up with 11. This one, you will have 1 over 7, because that's just what puts in. You don't need to do any reciprocals or anything like that, because it just stays as a fraction. If you are having problems, or if you're a little shaky, I totally recommend using your calculator. Just make sure when you're plugging it in that you do either appropriate parentheses, or you are using like fraction signs correctly, that kind of thing. Okay, so going into the next problem that doesn't deal with this anymore. It's saying when graphing with the Ohm graphing tool for rational functions, this is mostly for the people who have to use Lumen. First, plot the intersection point of the vertical and horizontal asymptotes, then plot a point on the graph of the function. Now, don't worry too much about that jargon. I will explain now. So we have our function f of x equals 1 over x. Let's talk about a rational function. So we've got our little graph here. And we have a little table of values. We have x and y, and we have 1 over x. Now, when x equals 0, we have a problem. So we can't have anything when x equals 0. This doesn't work. This is not allowed. And then, when x equals 1, we will have 1. That is allowed. We'll have 1 over 1, which is just 1. Now, if x equals negative 1, then we'll have negative 1, because it'll be negative 1 over 1, which is negative 1. So we'll have 1 right here. But now you might be wondering, like, wait a second. That doesn't work. We aren't allowed to cross that. And that's because horizontal functions are a little weird, a little crazy. Let's return back to the idea of finding a horizontal asymptote, which we covered in the previous video. The degree of our first one is going to be 0, kind of, and then the degree of our second one is going to be equal to 1. We know that when m is less than n, then the horizontal asymptote is going to be 0. So we also know that we technically could have a value here, we just aren't going to. It's not going to cross here. Yeah, we won't have anything at y equals 0. So what actually happens when you have rational functions, the parent graph looks like this. It's a little funky. It's got two little portions of the graph. Yeah, it's pretty unfamiliar to what we've dealt with before, but it makes sense if you are plugging in values and testing points. Now, the way that I like to explain, however, is when you have your parent function, and I think this is a way that your instructor explains it if you're in the class that I'm mentoring him for this semester. She draws a little box over the origin, which is 0, 0. And with that box, there's with that window, there's a little bit of a cross going on. It's a little T. And it goes right through the box, up and down. And those are your asymptotes. And then you go up 1, over 1. And over 1, down 1. And those are going to be your first starting points. Now we'll get into shifts in either this video or next video. I'm not sure. I don't remember. But basically, this is really key. This is super helpful for knowing how to graph rational functions, or at least the ones that we will be seeing. We won't typically see anything crazy, but we'll be seeing stuff like this. This is super helpful. Just do the little box, up one, over one, and then asymptotes. You got it. Simple, easy. Going back to our problem, the way that Lumen wants you to graph it is you want to do that box. You want to graph that box first and then go up one, over one, and place your point, and it will do it magically, automatically. It will graph everything else that you need. Up one, over one. Fill in the blanks for the rational function f of x equals 1 over x. So -3 will be 1 over -3. Let me change back to my maroon color because that's easier to see. So we've got if x equals -3, we have 1 over 3, and that's negative. If x equals 8, then we'll have 1 over 8. If x equals -1/6, then we'll have -6. If x equals -1/9, then we will have -9. If x equals -8, we will have -1 over 8. Moving on. Yeah, pretty simple. Select either true or false for the following statements for the rational function. Sorry, weird mouth things. So we have f of x equals 1 over x. We know that the horizontal asymptote is at y equals 0. That is true. The asymptote goes through 0, 0, like this. And we have our box in the middle, up and down, up and down. The vertical asymptote is also x equals 0. For x equals 0 and the function f of x equals 1 over x, the corresponding y value is 0. That is false because x is not allowed to be 0. It will give you a bad value. It will be undetermined. I don't remember if that's a term. It just doesn't work. What is the domain and range of the function f of x equals 1 over x? We know that we've got, sometimes it's helpful to think about our box. We know we've got an asymptote at 0, 0 for both horizontal and vertical. So we know that we'll be -infinity, we'll be really up close to it, but then we'll reach 0, and then we'll continue back up. Well, I guess it wouldn't look like this. It starts on the bottom first. And then we continue back up, and we do 0 to infinity. Same for this. -infinity to 0, and 0 to infinity. That would be your answer. Yep, that was kind of a quickie. If you have any questions, please let me know, and I will answer as soon as possible. Sorry for talking so fast.